we'd like to look at how to determine an empirical formula. Before we do that, we might want to talk about what does this term, empirical formula, actually mean. The empirical formula is really the simplest ratio of atoms within a compound. So for instance, if I had a compound that was like C2H6, the empirical formula for this would be CH3. Now, it's not the same stuff, it's not the same formula, we're not saying that at all, it's just the empirical formula. It would be the most simplified ratio of elements. This, of course, is the empirical formula for lots of different things. It'd be also the empirical formula for C3H9 and C4H12. The CH3 would be the empirical formula for all of these substances. It's just the simplified ratio of those things. Now, all of these things are not the same thing. They're all different molecules. In fact, CH3 isn't actually even a molecule. It's the empirical formula. These other things could be actual molecules. So the thing is, how is the percent composition of carbon different in all these? Well, it's not. The percent of carbon in all four of these things would be exactly the same. So what we're going to do is some problems where I'm going to give you a percent composition, and you need to try to figure out what the substance is. But the percent composition is really only going to be able to let us determine the empirical formula. And what I want to do from that then is figure out what's the actual substance. And so to do that, I would have to be given a molar mass. So in most problems, I'm going to be given a molar mass, which you don't really use in the problem until the very end, to try to figure out which one of these things it might be. So the best way to do this is to go ahead and, I guess, start a problem. So let's do this problem. Let's say we have, we're at a crime scene. We have an unknown substance that we found, and we take a sample of the substance and we put it into a computer, and the computer spits out some information, and it says that this substance is 70% oxygen. 70% oxygen and 30% nitrogen. So it's only made of two elements, oxygen and nitrogen. 70% oxygen, 30% nitrogen. Let's say the computer also tells us that the molar mass is 92 grams per mole. Okay, how do I go about solving this type of a problem? Well, what we're going to do is when you get a problem like this, you're going to either get a percentage, or they're going to always already tell you, the computer's going to tell you how many grams of each of the elements you have. If it doesn't tell you how many grams of each of the element you have, like the one we have right now, where it just tells us percentages, then you can assume you have, it doesn't matter because it's percent composition, so you can assume any amount of grams you want for your sample. Now, if you're thinking about this, there is a very logical choice to pick how many grams of the sample you want to have. If you get to choose, you should want to choose 100 grams. Because if I choose 100 grams, I can do the math really quickly. I would know then that there are 70 grams. If 70% and 30% of 100, I'd have 70 grams of oxygen, and I would have 30 grams of nitrogen. So you're either going to be given a certain amount of grams, and you can go ahead and start the problem right away, or you're going to be given a percent composition. If you're given a percent, just erase the percent sign and put the grams as the unit. That we'll just assume 100 grams, and that way it'll be nice and easy, and you can just start with grams by getting rid of the percent sign. So when we're doing trying to determine empirical formulas, what we do here is the same thing every time. We just take the amount of grams you have of all your substances, and in this one we only happen to have two elements, but we might be able to have more, and you convert them to moles. It's the first thing you do. I take both of them and convert them both to moles. Now, I've trained you to think of oxygen as diatomic, but that's only when it's oxygen gas. This is oxygen that's within a compound, so we have no idea how many oxygen atoms there are. That's what we're trying to determine. So I'll say 1 mole of oxygen is 16 grams. We'll When we're doing these problems, we just look straight off the periodic table. Whatever it is in the periodic table, that's what we're putting here. And 1 mole of nitrogen is 14 grams. So if I calculate this out on my calculator, what we normally want to do is we want to write this out to, about the thousandths place is to make it safe. So to make it work out well for us. So this would be 4.375 moles of oxygen, and this one would be 2.143 moles of nitrogen. You can test that out on your calculator. Okay, now, so sometimes people think that's all you have to do. This is the moles, and that's the important thing. But the thing is, if it was, how would you write your formula? Well, you'd write something weird like N 2.143 O 4.375, and that's bizarre. We know that these subscripts are always nice whole numbers in chemistry. So so even though we found out how many moles of each of these things we have, these obviously can't be the numbers. So really, the moles is actually not that important. What is important is, what is the ratio between these two numbers? That's the important thing. We want to know the ratio between the moles. And that's what's going to be able to give us our numbers. So the way to find a ratio, the way to always think about finding a ratio, is take both of these numbers divided by whichever number is smallest. So clearly, the smallest number is this one here. So if I take this number, 2.143, and I divide it by itself, I'll get 1. And if I take 4.375 divided by 2.143, look on your calculator, and it will come out to be very close to 2. Now, it might be 2.04, or it might be 1.98, but those are really, really close to 2, and so therefore you can say, well, it's a 2-to-1 ratio. Now, if it doesn't come out like that close, then you're going to have to do something else. We'll do that in the next problem. But this is a 2-to-1 ratio, which means my formula is 1 part N and 2 parts oxygen. So NO2 is my empirical formula. So all we did in empirical formulas is we took our grams of our elements and converted the moles. But we didn't care about the moles. We found out the ratio of the moles, and that's how we figure out what our empirical formula is. Now, keep in mind, I want to know if this is actually the right substance. Remember, the substance we found here at the crime scene has a molar mass of 92 grams per mole. So I need to add this up and see if it's actually 92 grams per mole. And if I do, nitrogen's 14, oxygen's 16, another 16 would be 32. That would add up to 46 grams per mole. So this isn't the right stuff. But you'll notice we know we have the right percent composition, but it's not the right molar mass. So you'll notice that 46 will go into 92 twice. It'll go in 2 times. So we want to maintain the percent composition, but we want the correct molar mass. We're going to have to multiply this entire empirical formula by 2. So our actual formula is N2O4. N2O4. So that's how you figure out the empirical formula of a substance. What if, and we'll just throw this out here, what if when we figured out our ratio, instead of coming out to 1 to 2, nice whole numbers, it came out to something like 1 and 1.5? What would we do then? We can't write NO 1.5. So if it comes out to something other than a nice whole number, it will at least come out, in any problem I'll give you at least, it'll come out to a kind of a nice fraction kind of a thing. So we still need to figure out what whole number ratio is 1 to 1.5. And some of you are good enough at math that you realize that, well, I could just multiply these numbers by digits until I get nice whole numbers. And if we take 1.5 times what will give us a whole number? Well, 1.5 times 2 will give us 3. So that's a nice whole number, which means I can take this one times 2 and get 2. So the ratio of 1 to 1.5 is also the ratio of 2 to 3. So in this case, our formula would be like N2O3. So if it doesn't come out to be a nice whole number, don't panic. Just think about the ratio that you need to have and figure out how can I turn those into whole numbers. What can I multiply both of them by so that I would have two whole numbers to do. And some of the problems I give you will be like that. So in review, what we did is we took our grams, we converted to moles. It's not about the moles, it's about the ratio of the moles. So you find the ratio, and then you can write the empirical formula. From there, you can see if it's actually the correct formula by looking at the molar mass.